Hello, my name is Conrad Michel Sumpa. Welcome to my YouTube channel. Please don't forget to like and subscribe so that you can receive more videos in our lessons. Today we are going to talk about approximations and estimations. The subsections that we're going to look at are rounding off, significant figures, standard form, and estimations themselves. What really is to approximate? What really is to approximate? To approximate is simply to approximate numbers, is simply to give a precise or close value of of something, maybe a distance, maybe the weight of an object, maybe the capacity of a container, or anything. For example, you can say this container, for example, you can say this stretch of the road is two is 2 kilometers. Just by looking at it, just by driving on it with a car and everything, because you've spent some certain amount of time, then you can just estimate that this stretch is 2 kilometers without necessarily you measuring it. You are just approximating. This object is 20 kg, 20 kilograms, just by you telling the approximate value. You see, that's it. Now let's look at rounding off. Rounding off. What's really is to round off? Round off, you may be asked in the examinations like round off to the nearest 10, round off to the nearest 20, round off to the nearest whole number, some sort. What is it? What really is to round off? When you are asked to round off, a number, say 33, round off to the nearest 10. You look at 33, you know that 33 is in tens, it's found between 30 and 40. Okay, 33 is found between 30 and 40, this range. Okay, and 33 is somewhere here, 3 3. Now when you are asked to round off 33 to the nearest 10, you look at it. How far is 33 from the nearest 30 or 40? When you look at 33 comes only after two numbers away from 30. You see, but they are but it comes but 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 there are like 7 steps for you to move from 33 to 40. So which one is much easy? Which 10th is much easy between 30 and 40? You look at the closest, the nearest to the 10th. 33 occurs, happens to be 30. When you are asked to round off 33 to the nearest 10, you just write 30. You see, because it's easy for you to move to 30 than it is for you to move to 40 from 33. You see, that's it. How about if you are asked to round off 35 to the nearest 10? Uh-huh. Which one is easy to go to? 35 occurs halfway between 30 and 40. Okay. Now, for 35, because it is halfway, you can, if you want, you can say 30. If you want, you can say 40. But it is more appropriate for you to write 40 because you have to move forward and not backward. That's the idea, you know. So when you are asked to round off a number which is halfway between the tens, between maybe 10 and 20, between maybe, yeah, like which is halfway between the nearest whole values, you see. So you just put it to the number which goes forward in front, the number which is ahead of it. If you are, yeah, it is also the same. If you ask to round off 321 to the nearest 100, 321 occurs between 300 and 400. So 321 to the nearest 100 happens to be 300 because it is easy to move for you to move from from 321 to go to 300 than it actually is for you to move from 321 to 400 because 400 is actually very far from 321. Yes. Now let's do some couple of examples on rounding off. Question 1. Round off the following numbers to the nearest 100. 321 itself, 538, 1024, and 20,006. Let's look at 321. 321 to the nearest 100, like I've said, it's 300 because it is easy for you to move from 321 to go to 300 than it actually is for you to go to 400 because 400 is very far. It is way above the halfway. How about 538? 538 again is less than 550 because it is also in the range. 538 is in the range of 500 and 600, you see. So it is actually easy for you to move from 538 to go back to 500 than it is for you to go to 600 because 600 is very far. 538 is less than halfway between 500 and 600. So you just say 500 here again and you have the answer. You've rounded off to the nearest 100. How about the next question? What was the next question? 1024. 1024. Which one is the 100th digit here? It's 0, right? Yes. So 1024 comes between 1000 when you are counting by hundreds and 1100. Okay? So 1024 is far much less than 1100. It's even less than the halfway of that range, which is 1050. Then 1024, 1024 comes somewhere here. So it's less. You would rather go this side than it is to go this side. Yeah, for protection in case of insecurity, in case of war. This 1024 guy would rather go this side to 1000 than he would actually go to 1100 in case he wants to be attacked by enemies. Okay, Let's look at 20,000 and 0, 0, 6. So our 100th range is here is a 0. So the range is between 20,000 and 20,100, you know. So this guy would easily go to 20,000 than he would go to 20,100 because of the range. Like he falls short by so many, by over 94 steps for him to get to 1,100. So the nearest 100 of this value is just 20,000. Let's go to the next example. Next question. Round off the following figures to the nearest 1,000. Okay, when you look at, let's look at 927. 927, when you look at it in the view of thousands, it lies between 0 and 1,000 itself. You see, lies between 0 and 1,000 itself. But 927, the halfway of 0 and 1,000 happens to be 500. So, but 927 is greater than 927 is actually greater than 500. So if it is greater than 500, in case 927 wants to be attacked, in case 927 is threatened by enemies and he wants to find protection to the nearest 1,000, he can easily jump to this 1,000 number than he would actually jump to 0, because 0 is very far. It's actually far less than 927 itself. Let's go to the next question. Let's look at 4,096. Okay, 4,096. 4,096 lies in the range of 4,000 and 5,000 because it is greater than 4,000, but it is less than 5,000. Okay. Now, and the halfway of 4,000 and 5,000 is 4,500. Now, look at 4096. Is 4,096 greater than or less than 4,500? Of course, it's less than 4,500. So 4,096 rounded off to the nearest 1,000 happens to be 4,000. You write like that because it can easily go to 4,000 itself than it would actually go to 5,000 when you round it off to the nearest 1,000. That's the answer. Let's look at the next one. 8,037. 8,937. 8,937. The range is 8,000 and 9,000 when you range it in thousands, okay? And the midmost number between the range happens to be 8,500. 8,937 is greater than 8,500. So when you're rounding off to the nearest 1,000, you write 9,000. Okay? Yes. Round off to the nearest 9,000. That is the answer. Let's look at other examples. 666. quadruple 6. I mean, okay, 6, 6, 6. This digit is in the range of 6,000 and 7,000, but greater than 6,500. Rounding off to the nearest 1,000 is 7,000. Okay, because it's greater than, it's more than half of the range. It comes more than half of the range. Let's go to the next part of the topic. Let's look at significant figures. Significant figures are simply important numbers. Significant figures are important numbers. Significant simply means important. You know, which ones are important numbers in these couple of examples that I have given. Now, there are certain rules that you basically have to understand about significant figures. When you look at significant figures, the first rule is that all non-zero numbers, all non-zeros are important, are significant in short. All non-zeros are significant. All non-zero digits in a number are significant. That's one thing you have to know. Then the second thing you have to know is that zeros at the end of zeros before non-zero numbers are not significant. Zeros before non-zero numbers are not significant. For example, when you write a number 0, 0, 0, 7, 0, 0, 1. Which numbers are significant here? The significant numbers only are these ones I have circled here. These zeros in front are not important. When you are asked to read this number 00070001, it still, when you are asked to read, it still reads as 7,001, as if there are no zeros in front, because zeros in front of a non-zero are not significant. Again, zeros between non-zero numbers are significant. Zeros between non-zero numbers are significant. These zeros are significant. When you are asked to read this number, it will still read as 7,001 because zeros in between are significant. Zeros after non-zero numbers are significant as well. Zeros after non-zero numbers are significant. These zeros at the end, significant. This number has 3 significant figures, for example. How about the decimals? Let's look at 0.00501. Yeah, like this. Let's look at the decimal numbers. Zeros, the same rules apply. Zeros, the same rules apply here. All non-zero numbers are significant. All non-zero numbers are significant. Zeros between the decimal point and the non-zero number are not significant. Zeros between the decimal point and the non-zero number are not significant. Zeros between non-zero numbers are significant. This zero is significant. Zeros after a non-zero number is significant. This zero is significant. Same rules, same things. Now let's go to exercises. Write the following numbers correct to three significant figures. Write the following numbers correct to three significant figures. Let's start. 3,410, 3410. Okay. When you are asked to write to three significant figures, which ones are significant figures in here? We've learned that all non-zero numbers are significant. Zeros after non-zero numbers are significant. So meaning that all numbers in this figure are significant. Now, but we have been asked to write to three significant figures. So meaning that we are going to write the first three digits in this number. The first three digits in this number are simply 3, 4, 1, 2, 3, S, F, to three significant figures. Okay, this is the answer. 3410 to three significant figures is simply 341. That's it. Let's go to the next question. 0.45021. 0.45021 to three significant figures. 0.45021 to three significant figures. We've learned again the same rules apply. To three significant figures, we are only going to end at 0.450. These ones, yes, they are significant, but they are not correct to three significant figures. They only want three. 0.450. That's where we're going to end here. It ends there. Let's go. 5.61029. Okay. 5 point. Okay. 5.6. Okay, here decimal point here. 5.62109. Okay. What are the three significant figures here? It's just 5.62. Okay. These are the three significant figures that we are looking for. Next, 11,021. Let's go to, I think we've seen examples enough here. Let's go to the next example. Let's go to the next topic. Standard form. Standard form is also known as scientific notation. Standard form, scientific notation, way of writing numbers, is used to write very big numbers, the very big scientific numbers, just expressing them in a manner that they can, in a simple way that you can write them on paper. There are some constants, some figures in science which are actually so large and so small in value, such that you can take you can even write them from one place to another. You can even be moving from one place to another just to write, for you to write that particular figure. You can move maybe a distance of 10 meters just for you to write that particular figure. But if you want to write it on paper, in a simple way on paper, you write it in a form that is known as scientific notation or standard form. You see, example is here. Write 3401 in standard form. 3401 in standard form simply means, friends, 3401 is can simply be written as 3.401 times 10 to the power. How many times has the decimal moved? Okay, here we put a decimal. How many times has the decimal moved from 1 to where it is? Okay, when you are writing, it's 1, 2, 3. So you move a decimal like 3 places in the left direction. Okay, and here you write 3 places. So why do you do this? Because that's the rule for scientific notation. When you are writing whole numbers in standard form, you move the decimal place in this direction, okay, in the left direction, up to the place where between the first and the second significant, between the first and the second non-zero digit, the first and the second non-zero digit. And then the same applies here. You move the decimal. If you are dealing with decimal numbers, you move the decimal places in this direction. If you are dealing with whole numbers, the index is a positive, and if you are dealing with decimal numbers, the index is a negative, because you are coming from the left hand side going to the right hand side. Now let's look at another example. Right, okay, this one is an Avogadro's constant. This one has, I'm giving you as a homework, this one has how many places? How many places is the decimal going to move? Okay, 3, 6, 9, 12, 15, 18, 21, 22, 23. So you are going to write it in the way like 6.022 times 10 to the power 23. To the power 23 what? Particles per mole. This is what is called an Avogadro's constant in chemistry. Okay, let's look at the next example. 90,500. Okay, 96,500. Okay, 96,500 in standard form is going to be, how many times is the decimal going to move? 1, 2, 3, 4. So it's going to be 9.65 times 10 to the power 4 times 10 to the power 4 C. That's a Coulomb, Faraday's constant. Let's look at decimal numbers. This one, 0.00645. Okay, 0. So how do you write this number in standard form? You move this decimal point to the first two, between the first two significant figures. How many times the decimal place is going to move? 1, 2, 3. You put it here between the first two significant figures. So it's going to be 6.45 times 10 to the power what? To the power minus 3. Because you are coming from the left direction going to the right direction, it's going to be a minus. Okay, that's it. That's the scientific notation. The same vein, this figure here, the decimal place is going to move like 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 5.8934 multiplied by 10 to the power negative 8. Okay, yes, that's your right in standard form. Let's go to the next example. Write the following numbers in scientific notation correct to two significant figures. Okay, 20,000, okay, welcome back. There was a technical problem. 20,000 in scientific notation is going to be written as 2.0 times 10 to the power 4. That is correct to two significant figures. These two friends, two significant figures. Next example, 45 to 521. Okay, 4, 5, 5, 2, 1. Okay, correct to three significant figures is 4 point. Okay, here you've got a 5. 5 round off to the nearest 10. This will be 4.6 times 10 to the power 4. Okay, yes. How about 4? Okay, the rest of the examples, look them out. You got to try them on your own. Let's talk about estimations. Estimations is just like I've already explained. You are just more like estimations is just giving a close range of or a precise value of something, you know. So when you're asked to estimate to the nearest example here, you're asked to estimate to the nearest 10, maybe the distance of some sort. You don't really, yes, of course, you know the value of, or maybe a distance of a road. You know the distance of the road, the exact distance, that is maybe 569. But when you are telling your friend or someone, you might say that I think it's roughly about 570, you know. You can't really, you may not want really to say the exact figure like 579, but you just say roughly 570. That's actually estimating. So I'm gonna ask you to try out these questions on your own, like roughly estimate the nearest 10. It's more or less like you are rounding off, like I have already explained. Yeah. So just kind of try to solve these questions on your own, like more or less like rounding off, no much difference, you know, that is estimation. Yeah. All right, guys. Thank you for watching my video. Um, don't forget to like and subscribe for more videos, and hit the bell button so that every time when I post a video, you get notified and view more. And don't forget to share my YouTube link to your friends out there who may be writing their grade 9 examinations, their grade 12 examinations, GCE and others. Yeah, we are helping you out there to pass your examinations with flying colors. Maths is a very easy thing. You got to enjoy the mimics of mathematics. Getting a 1 in mathematics is something that you can really be proud of as a candidate, as an examination candidate. Distinction, making you to get a distinction is actually our priority. Share out there to your friends who are in examination classes or who may be wanting to know this knowledge very much, so that they can get to know so that they can get to know what we are doing here. Watch more videos, elaborate explanations, very accurate. See you guys next time. These are my details. If you have questions that you want us to solve on YouTube here in our videos, feel free to forward them using any of my details, either on WhatsApp, email, Facebook. Message me on my page, Facebook page, like my Facebook page, follow me on Twitter, Instagram. Those are my personal accounts. All right, guys, see you next time. Bye. Bye, 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 bye. Okay.